So these two friends is Tato and Ben take part in a 400-meter event at the athletics meeting. There are 8 lanes. So very important, we should start to build our data to say all in all there are 8 lanes. But now there are 2. Doesn't mean the people who are going to be participating, there are 2. No? It's just that they are friends. We have 2 friends. And then all in all, we have 8 lanes. 1, 2, 3, 4, 5, 6, 7, 8. Probably we should have seen this when we are busy running. There was one lanes. We know it.
Yeah.
Right. So they say calculate the number of arrangements. So we can calculate the probability, we can calculate the number of arrangements. Those are 2 different things. No? With probability, you always have to say the probability is how many ways can the event occur all over the sample space. With how many arrangements, you simply just count how many different ways can that thing occur. So they say which calculate the number of arrangements in the starting lineup if Tato and Ben are placed next to each other. So we want Tato and Ben to be placed next to each other. Now, yesterday when we advised each other, you said to me, Marasa, why don't you put a bigger block here? When you put a bigger block, you tell them, I still have to arrange whatever is inside the bigger block, but I'm going to start inside. Now, we have 2 people here, which is Ben and Tato. They want to be together.
Yes.
Since they want to be together, you can say, don't put them here at the beginning. I've seen it becomes a mistake there. So we can rather take these 2. We can take Ben and Tato.
Yes.
So we have Ben, and then we also have what? T. But we could have had T and
B.
And B. So how many ways can this occur? It can occur 2 factorial ways. Yeah?
Yes.
But when we go inside the block, how many things do we still have to arrange inside the block? We have 1, 2, 3, 4, 5, 6, 7.
Yes.
All in all, we started with 8. We made, no, there's 7. How many things do we still have to arrange inside the block? How many things are still moving? Remember, Ben and Tato, they don't have to be here where I put them, but they just have to be together. They could be Ben and Tato here. They could be Ben and Tato here. So that is why I'm saying when we go inside, we count them as one. The only thing that we have changed is just to count them as one thing. But how many things do you still have to arrange? It's 1, it's 2, it's 3, it's 4, it's 5, it's 6, it's 7. So all in all, there are going to be 7 factorial ways in which we can arrange them. So what is going to be the answer of number 1? It's going to say that we have 2 factorial, which is for Ben and Tato and Ben. And then after that, it's multiplied by how many things do you still have to arrange? You see the mistake here. The mistake is that let us say 6 because you've used the 2. But you assume what Ben and Tato, they don't have to move. They can also move, but they are moving as a pair. That is why we're making them to be 1. Does it make sense? And then hence I said, you see what, it's easy for a learner to do this. I've seen this. If I put Ben and Tato in the beginning, I said this is Ben and then this is Tato here. And then I do this. Most of the time, learners, when they come, they say it's 1, it's 2, it's 3, it's 4, it's 5, it's 6. And then it makes sense. But you are not fixing them. They're not supposed to be in the first lane, first and second lane. They can be anywhere. So when you count them, but you count them with you don't count 1, 2. You count them as 1. Because they want to be always what? Together. We're fine then. Okay, that was number 1. Ben and Tato are placed next to each other. They say Tato and Ben are not placed next to each other. So number 2, we're not looking for them being placed next to each other. We're looking for not placed next to each other. Yes. Huh? Yeah, 1.1, it's 7 factorial. What is the answer? Give me the answer about that. It's 1, 0, 0, 8, 0. Like this?
Yes.
Okay. So these are the number of arrangements that we can have when Tato and Ben are next to each other. Everyone is happy then. So we want the number of ways in which they are not going to be next to each other. Now they are not next to each other. So we said the easiest way to calculate it is to actually say, okay, we know how many ways they can actually be with each other. And then how many different arrangements do we have in total? Regardless of whether they're together or they are not together. We want to check how many different arrangements do we have.
8.
You say we have 8.
Yes.
8 factorial, not 8.
Yes.
So we're going to say, number 2. We have 8 factorial ways in which we can arrange these people, regardless of Tato and whatnot. We have 8 different ways, 8 factorial ways in which we can arrange them. What do we get for it?
40.
It's 40,
320.
320.
Mm.
Like this. No?
Mm.
So the not part, not. So we can say that one is going to be given by 40320 minus the number of ways in which they are together.
Yes.
So if you take out the number of ways in which they are together, you're going to be left with the number of ways whereby they are not together. Because remember, doing something and not doing something, they are complementing each other. So what are you going to be left with here? You're going to be left with 10080.
30.
It's what? 30. 30.
240.
240.
0.
0. Okay, sharp. Okay, we are moving on to the last one, Manj. These were the questions that I felt would were a little bit of interest because we're dealing with the knot. And then when you're approaching a knot, if you try to calculate how many different ways can they not be together, like how to even structure it on your arrangements, we want them not to be together. It's going to be difficult for you. But if I say, okay, let's count the number of ways in which they can be together. Yeah. We want them to be together, and then we say, but how many different ways can these people be arranged? Then we subtract, it becomes simple that way. Wait. They're present. All right. Let's go to number 3. Tato is placed on line 1. Yeah? And then pen is not placed next to Tato. Yes. You heard me. So pen, where's pen? Pen shouldn't be anywhere next to Tato. Ne? But where's Tato? Tato is supposed to be in what? In line 1. So we can put pen anywhere except next to Tato. So even this one, we see it's a knot. Let's suppose we do it this way. We try to do it this way with number 3. I'm thinking something like this. Let's try to do it when they are together and Tato is in line 1. I'm sure we can put Tato in line 1. And then look at this. On number 3, I will say something like this. We have 1, 2, 3, 4, 5, 6, 7, 8. So we put Tato in line number 1. This is Tato. Now, if we want them to be together, because remember, they shouldn't be together, but Tato must be in what? In line 1. So I can put pen here. Now they are together. And there's no any other way they can be together because as long as Tato is in number 1, there's no way which I can put pen next to Tato unless they are number 1 and what then and number 2. How many Tato do I have? Like pen can't go to number 1. Hard. Pen can't go to number 1 because Tato must be in number 1. It's placed in line 1. Now, how many things can I still arrange? I can't arrange pen and Tato. Those two are fixed like that. It's Tato, it's pen. How many things do I still have to arrange? It's 1, it's 2, it's 3, it's 4, it's 5, it's what? It's 6. So they can occur 6 factorial way when Tato and pen are together and Tato is in line 1. Yes.
Number 1 and number 2.
Number 1. They are moving. They don't have to be in the first place. They are not fixed. They can move as an object, and then it can be pen, it can be Tato, it can be Tato, it can be pen. With this one, they said Tato should be in line 1. And then pen, because we want them to be together, pen should be in number 2. There's no, if I want to put pen next to Tato, I can't put pen in number 8. Because already Tato is in what? Is in number 1. So if I want them to be together, it means I should come and put pen next to Tato. And they can't move because Tato is, remember the condition is saying Tato is supposed to be in what? In number 1. So the others can still move. They can be another person next to Tato. They can be, but pen, Tato, fixed. Does it make sense? Okay. So all in all, we can say it's going to occur 6 factorial ways.
Yes.
What you get?
720.
720 ways. They are together. Pen and Tato, number 1, number 2.
Yes.
Now, how many different ways they are not next to each other? Yes. How would you do that one of not? So not how many different ways can they be arranged? We said it's 8 factorial. Minus 6 factorial. So 8 factorial minus 6 factorial is going to give us the number of ways in which they are not. Actually, 6 factorial is this one already that we've done. So it's 8 factorial minus 6 factorial.
39.
You get 3,
9.
9,
600.
6. 600. Yeah, so this is the number of ways in which Tato and Ben. Tato is going to be placed in line 1 and Ben is not going to be placed next to Tato. They could have also asked us the probability. Let's write the probability. Let's make it to be number 4. The probability that Tato and Ben are not next to each other. Or let's do this one number 3. The probability that Tato is placed in line 1 and Ben is not placed next to Tato. So that one will say something like this. We have the probability of Ben not. It's time. Time flies when you're having fun. So we have 8 factorial minus 6 factorial all over 8 factorial. Then this is going to be the probability that they are not, but Tato is in line 1.
Yes.